Hello, my name is Shreya Madwin. Today, we are going to be creating a motion alarm using an ultrasonic distance sensor, an RGB LED, a piezo buzzer, and a servo motor. In our previous circuits, we used all these components individually, but now in this circuit, we're going to be using them all in order to create our motion alarm. And we're going to see the outcome of that. Our ultrasonic distance sensor will be used to detect whether or not an object is near our circuit. And based on that value, our RGB LED will be changing different colors. If the value of our distance is greater than 20, then what it'll do is that our RGB LED will be glowing green. If the value is between 10 through 20 inches, then our RGB LED will be glowing yellow. And if it's really close to our circuit, and if our object is really close to our circuit, like if it's less than 10 inches, then our RGB LED will be glowing red. Our piezo buzzer will make a sound, and our servo motor will spin backwards and forwards. Parts needed. One ultrasonic distance sensor. We use our ultrasonic distance sensor to detect the presence of our obstacle or object to see how close it is from our circuit to our obstacle, the distance between that. One servo motor. Whenever our object is getting really close to our ultrasonic distance sensor, our servo motor starts spinning forwards and backwards, which makes an image pop up. One piezo buzzer. And again, whenever our obstacle or object gets close enough to our circuit, our piezo buzzer starts making some sounds. One RGB LED. Based on the distance between our object and our circuit, our RGB LED displays different colors between red, green, and yellow. And then we need 330 ohm resistors, which are used to limit the amount of current that's passed through our RGB LED. And finally, we need 15 jumper wires, which are used to connect the circuit together. Here is our RGB LED. Here are 330 ohm resistors. Here's our piezo buzzer. Here are our jumper wires. Here is our servo motor. And this is our ultrasonic distance sensor. Some other things that we might be using in this project are tape, paper clips, markers and pens, some paper, and also some scissors. Safety. When working on a circuit, make sure the board is not connected to a power source, such as a USB power source or battery power source. Now let's see the circuit diagram for our project. This one was sparked from the Inventors Kit website. Our ultrasonic distance sensor is attached at pins A3, which is the VCC, A4, which is its trig pin, A5, which is its echo pin, and A6, which is its ground pin. Our piezo buzzer is attached at pin F14, which is its positive terminal, and F16, which is its negative terminal. Our RGB LED is attached at pins A22, which is its blue leg, A23, which is its green leg, A24, which is its ground leg, and A25, which is its red leg. 5 volts from our red board is connected to the common power, and our common ground is connected to the ground on our red board. The power connector of our servo motor is connected to the common power, and the ground connector of our servo motor is connected to the common ground. And the signal connector of our servo motor is connected to PWM pin 9 on our red board. The VCC terminal of our potentiometer, or the power terminal, is connected to the common power. The trig pin is connected to digital pin number 11 on our red board, and the echo pin is connected to digital pin number 12 on our red board. And the ground terminal of our ultrasonic distance sensor is attached to the common ground. The positive terminal of our piezo buzzer is attached to digital pin number 10 on our red board, And the ground terminal is connected to the common ground. Sorry, the negative terminal is connected to the common ground. Digital pin number 6 on our red board is connected to the blue leg of our RGB LED. Oh yeah, sorry, by the way, I forgot to mention how our 330 ohm resistors are connected from E22 to F22. The second resistor is connected from E23 to F23, and the final and third resistor is connected from E25 to F25. And these are used to limit the current path to our RGB LED. So digital pin number 6 on our red board is connected to the blue leg of our RGB LED. Digital pin number 5 on our red board is connected to the green leg of our RGB LED. And digital pin number 3 on our red board is connected to the red leg of our RGB LED. Then the ground leg of our RGB LED is connected to the common ground. So this concludes our circuit diagram. Our ultrasonic distance sensor, our piezo buzzer, and our RGB LED are all polarized, and our servo motors connectors are also polarized. This is the Arduino IDE. The sample code is from the SparkFun Vendors Kit website. To go to our code, let's go to Files, Examples, SIK, like Codemaster, and let's go to 3C Emotional Alarm. So now let's begin with our code. The first thing that we're doing is that we're saying hashtag include servo.h. So what this does is basically gives a link to our header file for the servo library. So this basically allows us to include the servo library. The next thing that we're doing is that we're creating variables. They are constant integers. The first one is the trick pin is equal to 11. So what this does is that it basically tells, so this is basically a variable that will store the value of the digital pin that our trick pin is connected to. And then we also do the same thing for echo pin. That's connected to the 12 digital pin, and we store that in a variable. And we say for our RGB LEDs, we say red pin is equal to 3, the green pin is equal to 5, and the blue pin is equal to 6. So these are all the digital pins that our RGB LEDs, red, green, and blue pins are connected to. And then we create another constant integer, and then it's called buzzer pin. And then our buzzer pin is connected to the attention digital pin on our red board. And now what we're doing is that we are creating a variable, and its data type is float. And we're saying that distance is equal to 0. So this is like an initial value for the distance between our object and our ultrasonic distance sensor. Next thing that we're doing is that we're creating an object called myServo, and the servo in front of it is used to denote the servo class inside the servo library. And now in void setup, which only happens once, what we do here is that we say 0.begin 9600. So what this does is that it basically starts a connection just between it basically starts a serial monitor, which is a connection between our circuit and our computer. And 9600 is basically the data rates flow, which is 9600 bytes per second. Sorry, bits per second. And then we say pin mode is the trick pin, and then pin mode trick pin to output. So what this does is that it basically sets our trick pin to an output, and because that it sends pulses. And then we also say our echo pin to an input pin. And then we're saying all 3 of our RGB LEDs colors are all outputs. Then we're also telling our piezo buzzers pin is an output. And then we're doing myServo.attach 9. So what this does is that it basically tells that myServo is a method, and .attach is a method, and myServo is the object. So then, and then we're telling, this basically tells our code is that our servo motor signal pin is connected to the 9 digital pin on our red board. And now in void loop, which happens forever, what we do is that we say distance is equal to get distance. And get distance is a function that we've written before in our codes. like below in our code. So now let's just explore that a bit. The first thing that we're doing is that we're saying float get distance. So this is we're first creating a function called that, and then we're saying float is the data type, and that basically means that like it will return a float value, and then in that we're creating two variables. One is echo time and one is calculated distance. And now in our digital write, we say our trig pin to high, and this basically allows our trig pin to send pulses. And then we say delay by microseconds 10, so this basically delays our code by 10 microseconds. And then we're doing digital write of our trig pin to low, and this basically stops our trig pin from sending any more pulses. And now the variable that we called echo time up here, we declared that here. We say that is equal to pulse in of echo pin to high. So this basically does is that it allows our echo pin to detect the time from when our pulse was sent by the from the transmitter and when it was received by the receiver. So that time it takes to calculate, and then we store that time value in echo time. And we also say calculate distance, which was the other variable we declared up here, is equal to echo time divided by 148. So what this basically does is that echo time divided by 148 basically gets the distance in inches. And then we're basically trying to return that calculated distance. So if we go up, we are returning that value of get distance, and then we're telling that we're storing that in a variable called distance. And in the serial monitor, we're basically printing distance. And we're just, for measurements, we're just putting inches along with it. Then we're saying if the distance is less than or equal to 10, so basically if the distance between our object and our ultrasonic distance sensor is less than or equal to 10 inches, then we say analog write of our red pin to 255, green pin to 0, and blue pin to 0. So what this basically does is that it allows our RGB LED to be glowing red. And along with that, we also say our tone function, our buzzer pin to 272. So this basically makes our piezo buzzer play a sound of a certain frequency. In this case, it is 272. And now we're doing my servo.write to 10. So what this does basically is that .write is again another method, and my servo is the object here, and I'm saying that 10. So this basically does is that it makes our servo motor turn some specific angles, and then we're delaying it by 100 milliseconds. And then we're saying no tone of the buzzer pin. So what the no tone function does is that it basically tells, like it basically stops the tone, and then the parameter it takes is the digital pin. In this case, our buzzer pin, which is in this case 10 digital pin. And then we're doing another .write. And then this time we're doing it to 150, so it turns again to another specific angle, our servo motor does. And then we're delaying it by 100 milliseconds again. Then we're saying else if the distance is greater than 10 and less than 20. So if our distance is the distance between our object and our ultrasonic distance sensor is between 10 through 20 inches, then what we do is that we make our RGB LED glow yellow by saying red pin to 255, our green pin to 50, and our blue pin to 0. And that's what we do is that we say our analog write of our red pin to 0, analog write of our green pin to 255, and analog write of our blue pin to 0. So this makes our RGB LED glow green, and then we're doing delay by 50 milliseconds. And since this is in a void loop, the value can continuously keep on changing. If the object decides to move closer or moves further away, then that value will impact how our RGB LED glows and whether or not our servo motor will move and whether or not our piezo buzzer will be playing a sound. So this concludes our code section. Now to the assembly of our project. Here is our base plate with our red board and breadboard on it. Here is our ultrasonic distance sensor with its 4 pins, which are the VCC, the trig pin, the echo pin, and the ground, along with its transmitter, which is this, and its receiver, which is this. Here is our servo motor with its 3 connectors, which are the ground connector, the power connector, and the signal connector, along with the shaft, which can be used to insert mounts so we can see the moving of our servo more clearly. And here are just some mounts in which we can use. You can use any of them. This one. Here is a straightened paper clip. It'll be used to serve as a connector rod. And here's just a piece of paper, like it's a 2.5 inches by 2.5 inches paper. Here is our piezo buzzer with its housing and its 2 terminals. Here is our RGB LED with its 4 legs. And here is one of the 3 out of the 330 ohm resistors. And here are our set of jumper wires. So let's begin. I'm first going to take our ultrasonic distance sensor and I'm going to attach it from pins A3 through A6. So where A3 is our VCC, A4 is our trig pin, A5 is our echo pin, and A6 is our ground pin. I'm going to take this piezo buzzer and I'm going to attach the positive end from, I'm going to attach the positive end to F14. And the negative end goes to F16. Now I'm going to take this RGB LED and I'm going to take, its blue pin is attached to A22. Its green pin is attached to A23. Its ground is attached to A24, and its red is attached to A25. And now what I'm going to do is that I'm going to take this red jumper wire and I'm going to attach it from the 5 volts on our red board to the common power. Here is our black jumper wire and I'm going to attach it from the common ground to our ground on our red board. And now I'm going to take this red jumper wire and I'm going to attach one end of it to our servo motor. And I'm going to attach the other end to the common power. I'm going to take this black jumper wire and I'm going to attach it from our servo motor. And its other side is going to be connected to the common ground. And now I'm going to take this red jumper wire and I'm going to attach it from our servo motor to digital pin number 9 on our breadboard. Now I'm going to take this red jumper wire and I'm going to attach it from the VCC of the VCC of our ultrasonic distance sensor, and I'm going to attach it to the common power. I'm going to take this black jumper wire and I'm going to attach it from the ground of our ultrasonic distance sensor to the common ground. I'm going to take this yellow jumper wire and I'm going to attach it from the trig pin on our ultrasonic distance sensor to digital pin number 11 on our breadboard. Now I'm going to take this blue jumper wire and I'm going to attach it from the echo pin to digital pin number 12 on our breadboard. And now I'm going to take this blue jumper wire and I'm going to attach it from the positive terminal of our piezo buzzer to digital pin number 10 on our breadboard. And I'm going to take this black jumper wire and I am going to attach it from the negative terminal to the common ground. Now I'm going to take this blue jumper wire and I'm going to attach it from the digital pin number 6 on our breadboard to the blue terminal of our RGB LED. And I'm going to take this resistor and I'm going to attach it from E22 through F22, which limits the current which is passed to our blue terminal. I'm going to take this green jumper wire and I'm going to attach it from digital pin number 5 on our breadboard to the green terminal. And I'm going to take this resistor and I'm going to attach it from E23 to F23. And this again limits the current that's passed to our green terminal. And I'm going to take this black jumper wire and I'm going to attach it from the ground pin of our RGB LED to the common ground. And I'm going to take the spread jumper wire and I'm going to attach it from digital pin number 3 on our red board to the red pin on our RGB LED. And I'm going to take this resistor and I'm going to attach it from E25 through F25. So there's some reasons in which we can use this project. Like, for example, if we don't want anybody touching our stuff or something like that, then what we can do is that we can use this project. Like, for instance, if we don't want any of our younger siblings or our pets to touch us, then we can do it. So in my case, what I'm going to be doing is that, like, I'm going to be like attaching a scary monster sticker and I'm going to be and that's will start wiggling and tell people like not to touch my electronics couch. So I'm just going to take that sticker and I'm just going to attach it to this paper. So I just got stuck. So now I'm going to do, it's like, I also got this paper clip to be bent so that this side over here can be used to attach to our servo motor shaft. And this can be used to attach to the paper. This side can be attached to the paper. So now what I'm going to be doing is I'm going to take this shaft and I'm going to attach one side of this side right here to one of the holes. And now what I'm going to do with that, I'm going to attach this part to our servo motor. So now I'm just going to take a piece of tape and I'm going to attach this bottom part of my paper to my base plate. I'm just going to cut some tape now. So now I'm just going to take this piece of tape and I'm going to attach it to my sticker. Sorry, not to my sticker, I mean to my paper. And now I'm just going to attach it to my base plate. And now what I'm going to do is that I'm going to take another piece of tape and I'm going to attach it from this paper clip I have to my paper. Then I'm going to take this piece of tape and I'm going to attach it to our paper clip, and I'm going to just attach that to our paper. So, like, now we've just done this part. We finished building our circuit, and now it's time to upload code to it. I'm first going to take this USB, and I'm going to attach one end to my breadboard. And I'm going to attach the other end to my computer. So now I'm going to share my screen. I'm going to show you the Arduino IDE. And this is Arduino IDE. I recently found out that my red LED in my RGB LED does not work. So I might need to change some code for that. So the first thing I'm going to do is that for our yellow, which was if the value of the distance is between 10 through 20 inches, but what I'm going to do is that instead of yellow, I'm going to make it a shade of blue. I'm going to change this. Going to make this 0. I'm going to make this green pen also 0. And I'm going to make this blue pen 255. So the reason why I'm doing this is because like our yellow and our red, it both use the RGB LED, the RGB's red LED. So, and since it's going to be hard for me to do that, I'm just changing those two. And then I'm also doing this, which is I'm also doing red, which is the distance is less than or equal to. So in that, I'm going to say that my red pin is 0. Oh, and my green pin is 250, and my blue pin is 55. So what this does is that it basically makes a cyanish color. So now we can upload our code. As you can see, it's uploading. It is compiling the sketch. It is uploading, and it is done uploading. So I'm going to share my screen, and I'm going to show you my serial monitor. And here is our serial monitor. You can see that the value of the distance between our object and our ultrasonic distance sensor is greater than 20 inches. It is currently in around 51 inches. So, like, it works. And if I keep my hand as an obstacle now, then if I keep it somewhere around, let's see, sorry. If I keep my hand right here, you can see that the value is between 11 through, it's between 10 through 20 inches, meaning that now it's around 10 inches, close to 11 as well. So, and if I move my hand really close to it, you can see that the value is less than 10 inches. So now see how our circuit works. The obstacle, which is now furniture, is currently around 50 inches away from our ultrasonic distance sensor. And as per our code, that means that our RGB LED should be glowing green as it is. But if I keep my hand between 10 to 20 inches away, like right here, you can see that our RGB LED is glowing blue now, and it's not doing anything else. And next. And now if I move it really close within 10 inches, you can see that our RGB LED is glowing cyan, our piezo buzzer is making a noise, and our servo motor is also spinning back and forth and making the scary monster sticker move. So now if I just turn this around so you can see better, you can see that my ultrasonic distance sensor detects that my computer is an obstacle within 10 inches, and you can see that this monster sticker is moving a bit. And that if I turn this a bit, you can see that my RGB LED is glowing cyan.